In this problem, it says to determine the smallest value of k for which the equation x times x plus k equals k minus 1 will have one distinct solution. Now, if I multiply x out here, I get x squared plus kx equals k minus 1. So we have a quadratic. So the way we deal with quadratics is first we get everything equal to 0. So x squared plus kx. I'm going to bring over the k minus 1. So minus k plus 1 equals 0. Now it says that we want this to have one distinct solution. And now when that happens, the discriminant, different concept, b squared minus 4ac, that's part of the quadratic formula, is going to equal 0. So the number in front of x squared is a, the number in front of x is b, and this quantity here is c. So if we plug this in, k is b, so k squared minus 4 times a, which is 1, times c, which is this whole thing, negative k plus 1 equals 0. So if we multiply this out, we get k squared, negative 4 times k is plus 4, negative 4 times 1 is minus 4 equals 0. So what we get is we get another quadratic. Now we can solve this with the quadratic formula. Negative b, which is negative 4, plus or minus the square root of b squared, which is 16, minus 4a, which is 1, times c, negative 4, all over 2a. So when we simplify the inside, we get negative 4 plus or minus the square root of 16 plus 16 all over 2. So negative 4 plus or minus the square root of 32. Now, square root of 32 we cannot take, but we can simplify that to 4 square root of 2. Because within 32 is just 16 times 2. We can take the square root of 16, which is 4, and leave 2 under the radical. So then, we're still dividing everything by 2, so that's negative 2 plus or minus 2 square root of 2. Now, it says that we want the smallest value. So k can be either one of these. And so the smaller one is negative 2 and then subtracting. If you add 2, that's going to be the larger of the two. So we get negative 2 minus 2 square root of 2. There's our answer, and we're done.